Well, hey there, kiddos. Here is your video on Transformations Day 2. It should say at the top of your paper, changes of B, which if you remember is our Y-intercept. And so yesterday, on last night's video, we worked on changing M. So we changed the slope of the line and looked at what happened. So now we're going to change the Y-intercept of the line and then look at what happens. The notes look very similar to yesterday. You have the parent function y equals x already graphed, and then we're going to graph two others and then look at what happens. We're going to talk about what's changing and then and how the lines compare to each other. So like I told you, y equals x, your parent function is already graphed on here. The next one is going to be y equals x plus 1. Well, the slope is still 1 over 1. That hasn't changed, but our y-intercept now has. The y-intercept of this graph is at 1, so it's going to start here at 1, and then to get to the next point, we're just going to use our slope up 1 over 1. Or we can go backwards, down 1, left 1. And we're going to connect it and make our line. And hopefully you notice that these two lines are parallel. That's because they have the same slope. Slope of 1, slope of 1. The only thing I changed was the y-intercept. So there's that one. So this one is x plus 1. And then we're going to do x plus 3. So we're going to do y equals x plus 3. So the y-intercept is 3. And again, the slope is up 1 and over 1. So we'll plot our points, and then we'll connect them and make our line. And again, you should see that these lines are parallel again because the slope is still 1. The slope still hasn't changed. I have the same exact slope. The only thing I'm changing is the y-intercept. And so this one is x plus 3. And so what is changing each time is the y-intercept, the value for the y-intercept. And what happens to it is it went from plus 0 to plus 1 to plus 3. So it's increasing. And when I add or I increase the y-intercept, my graph shifts upwards. So it started at 0, then it started at 1, then it started at 3. So it's shifting up. And so how do the lines compare? They are shifted up. And they're shifted up the number of units that I am adding. That should be a D. Shifted up the number of units I'm adding to my equation. And so the first one that was shifted up 1 unit. This one with the red is shifted up 3 units from the parent function because I did plus 3. Another way that you'll see this said, instead of shifted up, it will say translated up. Because if you'll remember back in 7th and 8th grade, when you did transformations, you had translations, which were the slides. And so that's what we're doing. We're sliding it up. And so it's going to be translated up. That's another way you will see it worded. So now let's look at the next set. I've got my parent function again, y equals x. Starts there at 0, has a slope of 1. And now I'm going to do x minus 1, which means it starts down here at negative 1 because that's my y-intercept. But my slope is still 1, so I do up 1 over 1. And I can connect my points and make a graph. And again, you should see that these two lines are parallel because they have the same slope. So nothing, all I changed was the y-intercept. The slope didn't change, so my two lines are parallel to each other. And so we'll label that one. This is our x minus 1. And then we'll have to do one more. So the next one is x minus 4, which means my y-intercept is way down here at negative 4. But my slope is still positive 1, so it's up 1 and over 1. So I can connect my points, make a line. And again, you should see, as soon as I get my line to look pretty on here anyway, that my lines are parallel again because still I have the same slope. The only change I am making to my graph is what the y-intercept is. And so this time the y-intercept is changing, but instead of increasing, it's decreasing because I went from plus 0 to minus 1 and then to minus 4. So now it's decreasing. So the smaller I make my y-intercept, my graph shifts down. And so now what has happened is I've shifted down from 0 I've shifted down 1 unit to make the first one, and then I shifted down 4 units to make the second graph. And so these are shifted down whatever number of units happen to be in my equation. And again, another way that will be said is that it will say that it translated down, because that's our math word for slide or shift. So let's look at a couple of others. Now these are the same thing, except for I'm going to use function notation, because a lot of times when we do these transformations, function notation is what you're going to see. And so I have f of x equals x, which is the same as y equals x. That's our pretty parent function. And then the next one is f of x plus 2, which means I'm going to take my original function, x, and I'm going to add 2 to it. So my y-intercept is still 2, and my original function, f of x, is still x. So this is really like saying x plus 2. Well, my slope then is still 1, so up 1 and over 1. I'll connect my points and make a line. And you should see that you have parallel lines again. I bet you can't tell me why. Parallel lines, they're parallel because they have the same slope. You've heard me say it like at least 4 times now. So these have the same slope, so they're parallel, but this one is the f of x plus 2. And then the next one says f of x minus 3. So it's the same thing, and my f of x is equal to x. So this is like saying x minus 3. So my y-intercept's negative 3. It's going to go up 1 and over 1 for my slope. I can make my line. And it's parallel to the other two because it has the same slope. So this one is the f of x minus 3. And so what's changing every time is the y-intercept. And it depended. The first time I increased it, the second time I decreased it. So the y-intercept is just changing. And so how do the lines compare? They're translated. They get translated. It goes up if the y-intercept increases, and down if the y-intercept decreases. So let's summarize really quick so that we have our nice pretty summary. So we're going to first use what we know to deal with this. So my equation is f of x equals x minus 2. We want to know how this compares to the linear function, the parent function, f of x equals x. Well, if f of x equals x and then I change it to x minus 2, then it gets translated down because of the minus 2. And it gets translated down by 2 units because I went from plus 0 to minus 2. So the question next is, how would the graph change if the negative 2 in the equation was changed to a positive 2? So now I have f of x equals x plus 2. Well, then what happens from the parent function is then it gets translated up 2 units. Because now I made it a plus instead of a minus. So now what if I change the negative 2 to a negative 6? So now my equation is x minus 6. Well, then comparing that to the parent function, which is just y equals x, then it gets translated down 6 units. And then the last one, what's the relationship between these two lines? Well, the relationship between any of these lines is they are parallel. Y, they have the same slope. So in summary, the y-intercept affects, what it affects is the starting point of the line. It affects how high the line is up on the y-axis. So it affects the starting point. Or how high the line is on the y-axis. So to change the y-intercept just takes my graph and it shifts it up if I'm increasing it or down if I'm decreasing it, and that's all that happens when we change the y-intercept. So hopefully you can put that together with what we did yesterday when we changed the slope and affected the steepness. This slides the graph up and down. That's it. So we'll practice this tomorrow when you guys come to class. I'll see you then. Have a good rest of your day.